So our group had chemical processes, and we decided to do question one. Question one states that a mixture containing 32 weight percentage of 1-propanol, 45.5 weight percentage of methanol, and the balanced water goes through a process that produces two product streams. After analyzing the streams, one stream is found to contain 23.7 weight percentage of 1-propanol and 43 weight percentage of methanol. The second stream flows at a rate of 345 kilograms per hour. So part A wants us to create a flow chart for the process, and the flow chart serves as our step one since it defines the problem in breaking up what data we're given and what data we need to find. So we can see that we need the flow rate and the molecular composition, since part B asks us to solve for the molecular composition of the second stream. The input stream has to equal the output stream. And since we're given an initial flow rate of 1,000 kilograms per hour, we can solve for the flow rate of stream one by subtracting the flow rate of stream two, 345 kilograms per hour, from the initial stream flow rate, which is 1,000 kilograms per hour. So the flow rate of stream one equals 655 kilograms per hour. With that, we can solve for the molar composition of stream two. To solve for the amount of 1-propanol in stream two, we multiply the weight percentage of 1-propanol of the initial stream by the initial flow rate. And then we subtracted the product of the stream one flow rate and the weight percentage of 1-propanol in stream one. So it would be 0.32 times 1,000 kilograms per hour minus 0.237 times 655 kilograms per hour. And we got 164.765 kilograms per hour. Then we divide that by the flow rate of stream two, 345 kilograms per hour, to get the percentage of 1-propanol, which is 48%. Similarly, to find the weight percentage of methanol in stream two, you would do the same, except you would use the weight percentage for methanol instead of 1-propanol for the weight percentage of stream one and stream two. So for methanol, we got 50%. And to find the weight percentage of water, you would subtract the percentage of 1-propanol and methanol from 100. And for that, we got 2%.
So in order to find the molar compositions of the second stream, first the compound's masses must be found. And we find it by using this equation right here. Weight percentage of the propanol or methanol times 1,000 times the flow rate of stream two. And the reason why we multiply the flow rate of stream two by 1,000 is because we are converting kilograms to grams. So when you go down here, you multiply the weight percentage of each compound, which we found on the last slide, and you multiply it by 345,000 grams. So for the water, we get 6,900 grams. Propanol had 48%, so you multiply times 0.48, and you get 165,600 grams. Same thing with the methanol. It was 50%. You multiply by 0.5 times 345,000 grams, which gives us 172,500 grams. And this is a part of step 3 of the algorithm and approach. Same thing on this slide being step 3 of the algorithm and approach. Another step to find molar composition is taking the mass found in the previous slide and using it to find the number of moles. We do this by dividing the mass of the propanol, balanced water, or the methanol in stream two. And we divide that by the molar mass of 1-propanol, balanced water, or methanol, and that gives us the total number of moles. So right here, we found that methanol is a mass of 172,500 grams. You divide that by its molar mass, you get 5,384 moles. Same thing with the propanol. 165,600 grams divided by its molar mass gives us 2,756 moles. In the balanced water, we get 6,900 grams divided by molar mass, which ends up with 383 moles.
So next is step 4, which is our final calculations, which is finding the molar compositions of stream 2. The equation used to find this is the moles of balanced water, methanol, or 1-propanol divided by the total moles in stream 2, which is the moles of balanced water plus the moles of methanol plus the moles of 1-propanol. Multiply that by 100, and then you should get your molar composition. Total moles is the 2,756 moles of 1-propanol plus the 5,384 moles of methanol plus the 383 moles of balanced water, which you should get an equal of 8,523 moles. And all these individual moles of the mole species were calculated on the previous slides. Now to find the molar composition for 1-propanol, you're going to divide the species mole, 2,756 moles, by the total moles, which is 8,523 moles. Multiply that by 100 and you should get 32%. Now we're going to do the same thing with methanol, except we're going to do 5,384 moles because that's the methanol moles that we calculated. Multiply that by 100 and you should get 63%. Next, you can do the same thing with balanced water, but you could also infer, or not infer, you could also figure out that 32% plus 63% equals 95%, meaning only 5% left should be the balanced water. But this is also a great way to check to make sure your calculations are correct, so we're good. So the final step is step 5, which is verify and test. So for steps 3 and 4, we basically just use the calculator, and then at the end, I put all the information in Excel as like a second verifying calculator, and our calculations ended up matching. So everything is correct. Everything makes logical sense, the 32%, 60%, 5%. And also the real world importance for doing this is now we have an insight of how we're going to be using chemical processes as our jobs as future chemical engineers. And thank you so much for listening. I hope this was informational.